A box contains gold coins. If the coins are equally divided among 6 people, 4 coins are left over. If the coins are equally divided among 5 people, 3 coins are left over. If the box holds the smallest number of coins that meet these two conditions, how many coins are left over when equally divided among 7 people? So from the problem given, we have two conditions. First one is if it's divided equally among 6 people, there are going to be 4 coins left over. If it's equally divided among 5 people, then there's going to be 3 coins left over. And we can start with an initial guess of 4 because we know that there must be at least 4 coins to leave a remainder of 4 when divided by 6. So since we need to check for a remainder of 3 when divided by 5 also from this condition, then we're going to add 5 to our initial number. So our guess was 4, but we're going to add 5 since it has to satisfy this condition too. So 4 plus 5 is 9. And this is because any number more than one more than a multiple of 5 will leave a remainder of 1 when divided by 5. So similarly, any number that is 3 more than a multiple of 5 will leave a remainder of 3 when divided by 5. So we're checking 9 if it's such a number. And we know that 9 did not satisfy this equation since it will leave a remainder of 4 if it's divided by 5, and we need a remainder of 3. So we're going to go up by 5 since we need a multiple of 5. Since we need 5 as the even divided among people, so 9 plus 5 equals 14. That will be our next guess. So 14, again we're going to add 5 again to get the next number. That will leave a remainder of 4 when divided by 5. So if we check 14 and it leaves a remainder of 4 when divided by 6, and a remainder of 3 when divided by 5, we see that it does not work. Since 14 divided by 6, we do not get a remainder of 4, we get a remainder of 2, and 14 divided by 5, we get a remainder of 4 and not 3. So if we add 5 again, we have 19 now. And we can keep adding 5 until this process and check our new conditions. And the process is going to check for every 5th number from our initial starting point since we're adding 5. Because there's 5 conditions and we need to satisfy the second condition. So if we're going to keep going in our incremental search, and if we go to 28, if we reach 28 after keep adding 5 to these numbers that we had, 28 minus 4 is 24, and we know that's divisible by 6 since it leaves a remainder of 0. And 28 minus 3 equals 25 divided by 5, a remainder of 0. So therefore 28 is going to be our smallest number of coins that meet these two conditions in our problem. So 28 coins we have, and how many coins are left over when equally divided among 7 people? 7, that's going to be 4 with a remainder of 0. So A is our answer.